Welcome back to Otomo Tutorials. We've looked at the basic way in which ionic and simple covalent substances are bonded together and how they're arranged in terms of their structure. We're now going to look at some of their basic physical properties. And if we look at melting and boiling points, ionic compounds will generally have high melting and boiling points. And that is because of the many electrostatic attractions between ions of opposite charge in a lattice. This overall attraction is very strong, and it takes a large amount of energy to overcome it and break the ionic bonds. And what this is basically saying is that an ionic lattice has to be heated to a very high temperature before the attractions break down and you go from a solid lattice to a liquid, or even from a liquid to a gas. So that's melting and boiling points. In terms of the next one, which is solubility, solubility means how easily a substance dissolves. And you don't really need to know much about this, except for the fact that most ionic compounds dissolve quite easily in water. In terms of electrical conductivity, ionic compounds can conduct electricity, but only under certain conditions. Conductivity relies on ions being able to move freely, ions or other charged particles like electrons being able to move freely to carry electric charge. With a solid ionic substance, the ions are essentially held in fixed positions and are not able to move. So if you look at this lattice, it's in a solid state. This ion here cannot move to the other side of the lattice, for example. It's fixed in its place. And it's because of this that solid ionic substances cannot conduct electricity. However, when an ionic lattice is melted down or dissolved in water, their ions are able to move around and can carry electric charge, and so will be conductive in that state. So those are some general physical properties for ionic compounds. If we go into simple molecules, we can run through some properties in a similar way. When looking at things like electrical conductivity, it's very important to remember the physical arrangement of simple covalent molecules, and the arrangement is very different from ionic lattices. So simple covalent molecules don't conduct electricity, and that's because there are no ions or electrons that are free to carry electrical charge. There are no ions in simple covalent molecules, and the electrons are confined to the shells, essentially. Simple covalent molecules are detached from each other and are essentially just a handful of atoms bonded together with no ions or free electrons to move, and so electrical charge cannot be carried. This is obviously a very different picture when we look at ionic lattices. Looking at melting and boiling points, simple molecular substances tend to have quite low melting and boiling points and are usually liquids or gases at room temperature. Now, as I've said, simple molecules are detached from one another, but the atoms within these separate molecules have strong covalent bonds between them. But this doesn't actually determine the melting and boiling points. What determines the melting and boiling points are these intermolecular forces between the molecules. And intermolecular forces are basically forces of attraction between separate molecules. For example, in a glass of water, you will have millions of these water molecules with intermolecular forces between them. The strength of these intermolecular forces are weak compared to the strength of the covalent bonds within just one molecule. For this reason, overcoming or breaking these forces of attraction, these intermolecular forces, doesn't require too much energy. And it's only these attractions which need to be broken in order to melt or boil the substance. And so that's why melting and boiling points are so low.